So hello guys, today we are going to discuss this problem, find eventual safe states. So the problem goes like this, that we have a directed graph where we have n nodes and all the nodes are starting from 0 to n minus 1 and graph is represented by 0 index 2D array which is given here, and the graph I where the graph I is an integer array of nodes adjacent to node I, okay, meaning there is a edge from node I of each node in graph. Okay, so what does this mean? That node 0 in the graph has two edges, two neighboring nodes or two edges, 1 or 2, that is, it goes to 1 and it goes to 2. Then this is for node 1. So node 1 has two edges, which goes to 2 and 3. Node 2, this is 0, 1 and 2, has one neighbor, which is only 5. So node has 2 has only 5. Then node 3, 0, 1, 2, 3 has only 0. So 3 has only one outgoing node, that is 0. Then 4 has only one outgoing node, 5. Then node 5 and 6 do not have any outgoing nodes. So the question says is that a node is a terminal node if there is no outgoing edges. Okay, so let me just copy this and paste it here. Okay, and I paste it. Just give me a second. Oh, I cannot paste it. That's fine. So it means what? Um, okay, let me write it here then only. So if we consider this graph here, the node is a terminal node if it doesn't have any outgoing edges. So here, this is a terminal node and this is also a terminal node, right? So we have two terminal nodes, that is node 5 and 6, because from node 5 we do not have any outgoing edge, and from node 6 also we do not have anything. Then it says a node is a safe node if every possible path starting from node leads to a terminal node. So consider here in this case, what are the safe nodes? So safe node is that node which has all the paths which goes to the terminal node. So 4 is a safe node, right? Because it has only one outgoing node which goes to a terminal node. Now let's consider 3. So in 3, what can be one path? 3 goes to 0, right? 0 goes to 1, 1 goes to 3 again, right? So from 3 we can reach 3 again, so this is not a terminal node, right? Because it has a cycle. Even and also 3 can reach 5 as well. For example, 3 goes to 0, 0 goes to 2, and 2 goes to 5, right? But all the paths should reach terminal node, but there is one path which reaches node 3, so it is not a safe node. Now let's go to node 2. So from node 2, there is only one outgoing path which goes to terminal node 5, so this is also a safe node. We can say this safe node. Then let's go to node 1. From node 1, what are the outgoing paths? One path goes to 2, then from 2 it goes to 5, then from 1 we go to 2, from 2 we go to 0, and from 0 we go to 1. So right, so one path is from 0, 1 to 2, 2 to 0, and 2 to 1. So there is one path which doesn't lead to the terminal node, so this is not a safe node. Now let's go to 0. What are the outgoing paths from 0? There are two outgoing paths from 0, that is from 0 to 1, 1 to 2, 2 to 5. This is safe. Then 0 to 1, or let's go to 0 to 2 and 2 to 5. This is also safe. Let's go to another path, 0 to 1, 1 to 3, right? 0 to 1, 1 to 3, and 3 to 0. So this is also not a safe node. And terminal nodes are already safe nodes because it has only one path which already goes to the terminal node. So we have four safe nodes here. That is 2, sorry for 2, 4, 5, and 6, right? Only four safe nodes. Now, we got this concept of the terminal and the safe node, but how we are going to derive it? So, one way to derive is to check all the possible paths from every node to the terminal node, and if there is one path which doesn't goes to the terminal node, then we say it's not a safe node. The other way is if we can find that a node is a part of a cycle, right? And how, if node is a part of cycle, then it is not a safe node because, for example, 4, if it is on a terminal node, it goes to a terminal node, and this doesn't, there is no cycle back. For example, there is a cycle back to here, then this will not be a safe node because there is one path which comes back. So if we have only one directional path which goes to the terminal nodes and we do not have any cycle, then we can say it's a safe node. So unsafe nodes are those nodes which has cycles, right? So how we are going to do is we are going to apply a topological sort and we are going to find a cycle using the topological sort, and all those nodes which do not have a cycle, when we will do it using the topological sort, we will say those are the terminal nodes, and those nodes which have a cycle, we will say those are not the terminal nodes or safe nodes. Okay, so now let's go to uh, the example to understand it better how we are going to apply a topological sort. So if we see this one, 1, 2, 2, 3, okay, let me draw it as well. So here we have 1, we have 0, sorry. This is 0, 1, 2, 3, 4, 5, and 6. So from 0, we have two outgoing nodes, which goes to 1 and other goes to 2, right? From 1, we have two outgoing nodes, which one goes to 2, other goes to 3. Then from 2, we have only one, which goes to 5. Then from 3, it only goes to 0. So we have to make something like this. Then from 4, it only goes to 5, that is 1, which is 4. And from 5, we do not have anything. And from 6 also, we do not have anything. So if we try to find out the reverse thing, and that is the way we solve the topological sort is we find all the incoming nodes. So for node 0, what are the incoming nodes? So only incoming node is node 3, right? As we can see. So if we say uh, we have for node 0, 3, right? Only one incoming node. For node 1, what are the incoming nodes? Only one incoming node, which is node 1. For node 2, what are the two incoming nodes? 0 and 1. Then for node 3, what are the incoming nodes? Only one, that is 1. For node 4, there is no incoming node. For node 5, there is only one, which is 2. And for node 6, we do not have anything, right? Let me just check one more time. So for node 0, let me write it down. This is 0, 1, 2, 3, 4, 5, and 6. So for node 0, we have one incoming node, which is 3. For node 1, we have 0. For node 2, we have 2. For node 3, we have 1. For node 4, we do not have any incoming. For node 5, 2, and node 6, that's fine. Right, and now we are going to find the out degree. So out degree of a node is the number of edges which are going out of a node. So for node 0, uh, it will be just a vector. For node 0, its out degree will be 2. For node 1, its out degree will be 2, because for node 0 we have two nodes, two directions which are going out. For node 1 we have two directions, that is to 2 and 3 are going out. For node 2 we have one which goes to 5. For node 0, 1, 2, 3. For node 3 we have only one which goes to node 0 here. For node 4 we have one which goes to 5. For node 5, 0, and for node 6 is also 0. Right, so how we'll do is we will take a queue and we'll push all the nodes which have out degree as 0. So here we have 0, 1, 2, 3, 4, 5, and 6. Sorry for my bad writing. So here we'll push 5 and 6, because when we traverse the out degree we'll find that the node 5 is that has out degree 0 and node 6 has out degree 0. Now we'll sit in a while loop, that is while queue is not empty, until queue is not empty. Queue is not empty. So what we'll do, we'll pop the front. So front will be equal to 5. And then we'll go, this is the incoming, right? Incoming. And then we'll check all the incoming nodes, right? So we'll check all uh, nodes incoming to 5, right? So what we'll do, we'll go here and we'll check all the incoming nodes to 5. So 2 has one incoming node and 4 has one incoming node, right? So to 5, oh, sorry, let me modify it here. So it is 2 and 4, right? So now when we remove this node from the graph, this 5, the out degree of this 2 and 4 will reduce by 1, right? So what we are basically doing, we will remove this 5 and we will reduce the out degree of 2 and 4. So out degree of 2 was uh, 1, so we'll do it minus 1, and 4 was 1, so we'll do it 0. So now our queue will be, and whatever the nodes which becomes 0, we'll push it onto the queue. So in our case 2 out degree became 0 and 4 out degree became 0, so we push it on the queue, right? And whatever the nodes which are there whose out degree is 0 is our answer. So we have our, in our answer set we have 5, we have 6, right? um, okay, so now we'll pop the front, we'll get 6. We'll check all the nodes which are incoming to 6 which are not there any node. So we have our queue as 2 now, so we'll pop the front, we get 2. So we'll check all the incoming nodes of 2. Basically we are removing 2 here. So for 2 we have 0. So for 0 we'll reduce it by 1, so it becomes 0. Oh, sorry, it becomes 1. And for 1 we'll reduce it by 1, it become 1. So none of the node becomes 0 now, so we will not reduce it, right? So now not add any node into the queue. Now we have only one node, so our output is also here 2. So now we have only one node, which is 4 in the queue. We'll check all the incoming nodes to 4. So there is basically no incoming node to 4, right? So here, if we go and see there are no incoming nodes to 4, so we'll not reduce anything and our queue becomes empty. And our answer is 5. So basically what this approach tells us, it means that node number 0, 1, and 3 has at least one cycle which comes back to themselves again, right? So that's how we are going to arrive at the solution. So let us just look at the code now. So here, uh, this is our incoming graph. We will create a 2D vector of incoming nodes, which is of same size as graph. So our incoming node will be uh, same as we have explained, as you have seen in the diagram. And our out degree will be the number of links which are going out of a node. For example, from node 0, we have two links, one and two going out, similarly, and so on, right? So what we'll do, we will create an incoming node vector here, and we will have the out degree I is equal to graph I dot size. It means that whatever the size of this, so 0 will have two nodes outgoing, one will have two, and so on. And if we have out degree 0, for example, in case of 5 and 6, we'll push it on the queue. Now, until the queue is not empty, we got the front of the queue, and we go to the incoming node of front, right? Whatever nodes which are coming into into this node, we are going to that, and we are just reducing the out degree of all those incoming nodes. And if the incoming node becomes 0, we'll just push it. And finally, we whatever our out is there, we'll sort it and return the answer. So basically, this is how the topological sort works. We always have to take a uh, incoming node graph, that is incoming node vector. Then we have to take out degree. We have to reduce the out degree. And if out degree becomes 0, we have to push in the queue, and we have to iterate to the queue. So basically, the thing here is, um, this question, these kind of questions, we have to identify the underlying problem in this. So this terminal node, safe node, these are only terminologies, but finally the question is about finding a cycle in a graph. So all those nodes which do not have a cycle, just them into the vector, and that's the answer. So some other problems which belong to the same category for the topological sort are these. For example, co-schedule, detecting cycle in a graph, then order of alphabets in the alien dictionary, and so on. So thanks a lot, guys. Have a good day.